Good afternoon. So it's day 9 of the problem solving series, and we are solving a minimum element in the binary search tree. So it's like the previous questions which we have already solved. I guess in the second day we have solved the shortest diagonal sum of a binary search tree. Let me recollect once. What was that question? That question was binary tree diagonal element sum. So basically, we have to do the sum of the diagonal elements of the binary tree, which we have solved in the first video. Today's video is about like finding you know the minimum value present in an element of a binary search tree. So let's go with the question. The first line of input says there's a binary tree, and binary tree 5 is divided into 4 and 6, and 4 is divided into 3, and then 3 is further divided into 1. So you can see the lowest value of the, or the, you can see the most, like when you traverse through the particular tree, the deepest part of the node is 1. So, and 1 is also the lowest point of the node. For the second example, you can see the node starts with 9, 10, and 11, and it further goes deepest to 11. Although it is starting with the lowest value and then it is increasing, so we have to keep in mind that the minimum value can also be at the start, can also be in the middle, and also be during, like, when we reach the depth of that particular binary tree. So what are the time complexity? Okay, the time complexity is O to the power of n, because it's written the height of the binary search tree. So how we'll find the height of the binary search tree? Height is basically the deepest part of the root. So if the root is like 5, 4, 3, and 1, so deepest part of the root will go till 1. That is going to be the height of the binary search tree. And here are some company tags and etc. So let's go with the editor part. First, you can see the template has already defined class node of the, and there is one data variable which is basically, I should mention, storing the current value of the node. Left is basically denoting that we have to move towards the left side of the node. Right is denoting the right side of the node. And there's one constructor node which is having an initial parameter as int data. This particular data constructor has been storing the current object of the data file, and also we have initialized left and right pointers as null. Now let's come to the class solution. We have already been given one function int min value node root. So what min value node root does is basically it calculates the minimum value present in a given node. So if you see, first we have to check whether the node present over here is, like, say, root equals to null. So what basically we are going to see, if the program encounters a root which has no value, then we will print -1, or we will return -1, says this is a function of integer type. It's not void. So if the function would have been void, it would have returned a value, like we would have printed that value. Now let's make previous counter equals to null. So basically this previous counter, what it does is basically it checks the previous value of the particular element. Now we have to traverse through the loop until this previous, until the root, particular root, doesn't becomes null. So yeah, now we have to store the value of previous in the root. So we can write like this: previous equals to root, and the root equals to data. Or you can say, but like we have to, since we have to go further down under the root, so we should store root equals to root dot left. As you can see in the left side of the tree, there is the depth we can see. So we can like go towards the depth of the binary search tree. And what else is there? The while loop, I guess, ends over here. Yeah, finally if the root is found, then we have to return the previous value which is stored in data. So let's check the braces. The braces are completed. This was short and easy problem, the binary search tree. If you know the basic concept of how to define this particular node constructor already, which is defined in questions in may other coding questions you might not have the node defined previously, and you have to initialize it again. So in this case it was already defined, so it made our task a bit easier. Let's compile. Or is there saying previous data? I missed a semicolon, so again we have to compile. Yeah, so it's matching the output. Let's check the test cases. So yeah, we are currently on the 45 days of the Geek for Geeks streak challenge, and in this problem statement, we learned how to go towards the depth of a binary tree search tree, and in a BST, we are finding the minimum value present in that BST. So let's recall again. First, we have defined a class solution. Then we have defined that function known as int min value. In the min value, we have taken node root as our parameter root function. If the node root has no values inside this, then we will